Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Good afternoon, our dear participants of this amazing WeAreDevelopers World Congress. It's almost time for the big game, Germany, soccer, whoever watches it. So I'm excited for that. But there's one thing I'm even more excited, and this is this 5 p.m. talk that we will have right now. Because if you were ever in the situation that you have encountered one of those code bases that kept you up all night, and there was little to nothing that you could do about it, especially when it comes to testing, then this session is for you. Because, and this is not my promise, this is the promise of our speaker, when you leave this talk, you'll have a way to approach testing and rescuing some of the toughest code bases in your career. I really hope that he can, keep this promise. If not, then I think the Q&A session afterwards will be pretty exciting. With that being said, I would like to welcome our speaker here on stage. His name is Ryan Latta. He's an independent consultant, and the title of his talk is How to Test a Ball of Mud.
Thank you for the introduction. I'm going to go ahead and take these off so I can focus on what I'm doing here. So welcome to How to Test a Ball of Mud. My name's Ryan Latta, and I'm not going to spend a lot of time introducing myself now. I'll do that at the end so you can decide if this lived up to your expectations. You can decide if you want to know more about me and all that. And at the heart of it, this talk is about an eventuality. And that eventuality is, as developers, we will wind up in a situation where we will feel like this poor woman looks, like we are trying to slog through a code base that is just hard, we're not getting anywhere, and it's just a brutal experience. Now, before I go too much further, I wanted to kind of describe the two characteristics I'm really talking about with the ball of mud. And they are, one of them is that the ball of mud means it's too complex for us to keep it all in our head. That doesn't mean just code. It could be also the infrastructure, which we'll talk about a little bit in a second. It also means that we can't predict our own results. We may think we're making a trivial change, but sure enough, there are ripples throughout the entire system. And these are two characteristics that put us in a position where everything is really, really hard. We spend so much time trying to rebuild our understanding of what is happening in our code base and in our system, and it's really, really hard even to do something small, and it also seems somewhat impossible to make any headway with it. So if we ever stand a chance of dealing with a ball of mud, we have to do something different. In other words, if we wrote a bunch of code to get there, we probably have to stop thinking about how we're going to write code to get ourselves back out. We have to do something fundamentally different, and for a lot of ball of mud scenarios that I've seen, that means we're probably going to have to test it. Now, I'm going to go a little bit further here in a second, but before I do, please use the chat, ask questions, please share what you've seen along these lines. Please go ahead and say if you think I'm crazy. All that's great. So what I'm going to describe in this talk are two ways to start testing a ball of mud. With these two first steps, you'll be able to begin to untangle one and unball of mud it. But before we do that, there's this kind of rule, and we'll talk about it, that if you're going to test something, you've got to care about the results. An all too common characteristic of a ball of mud is that there are tests that have been failing for a long time, or they're neglected, or anything like that. If we're going to invest in these kinds of tests, we have to actually start taking the results pretty seriously, which means we have to stop work and deal with what's going on. Now, the first of two types of tests, and you can start these at the exact same moment. This effort can happen in parallel. The first type of test that I'm going to recommend that any group starts is system tests. Now, there's probably a better name for this, but this is the word I use. I've been using it for, I guess, about 7 years now. And system tests have one job. They answer the question, is our infrastructure operational? Which is different from correct. So what we want to know is, are the servers running? Can they talk to each other? Is the database up? Because the bottom line is, if the infrastructure is down or unstable, then all of our code doesn't actually matter. Now, this is a tricky thing because, sometimes we believe we are in a stable infrastructure, or we have on faith that all those pieces we have all work. But in my experience, those are not very safe assumptions, especially in lower or non-production environments, which means we might be trying to do a lot of our best development work navigating a ball of mud in an infrastructure that simply won't support a change. So the first time I ever did this was about 7 years ago, and I was working on a code base that was 6 years old, and it had gone through several pivots in a company. It was very much a ball of mud situation, and there were problems every day. Every day, almost all of our conversations were obsessed around why is this broken? What are we going to do? When are we ever going to get to fix all this? And there was an interesting quirk to that, which is when everything's broken and everyone thinks that there is a different cause, that's a clue to me. That means not many people really know what the problems really are. They don't know what a root cause would be. Everyone has their pet reason why it's a problem. It's a bad database. The VPN is bad. Amazon is immature. 7 years ago, this was still a thought. So when there's so many different reasons why common things go wrong, that means no one really knows. So I decided to put a set of tests in place just to confirm we weren't dealing with an unstable infrastructure. Now, the tests that I wrote were simple because all I wanted to see was if our infrastructure was operational, not correct. So I wrote a script, I think it was even in Bash, and it would go to SSH into a machine and then ping out to the other machines that it would ever have to talk to. And if it could do that, that meant that A, the first machine was running, and B, it could talk to the ones it needed to. And I did that for all the main things that our system needed. I had it log into our database using the same credentials that our software would, so I could confirm that the database was actually running and we could access it. So I did that, and it only took me about an afternoon to put it together. What I did then was plug that into our CI system, and I set it up to run every 5 minutes. So if you're learning about continuous testing, this is a really kind of a easy way to get into it because we're not manipulating state. We don't even really care. We're just asserting infrastructure is operating. It would run every 5 minutes. And the hiccup here was, just like most ball of mud scenarios, there were things that were running. There was monitoring, there was alerting, there was some tests that ran, but all of this stuff had so many errors in it that everyone had developed a really good filter for ignoring most of those errors. So by putting the stuff in CI, that actually didn't accomplish anything. What I had to do was make it so we couldn't ignore the results. So in this case, and I'm not going to recommend you do this, though it is an option, I made it play a noise every time that this test failed. So 5 minutes after I started it up, it played a noise on every single person's computer. And I mean, they jumped. They were like, what is this? 5 minutes after that, it played another noise. And 5 minutes after that, it played another noise. And on this went. Now, there were two reactions to this. One, and I have found this reaction to be about the same everywhere I've been. One group of the developers, about half of them, thought, oh man, we need to fix the problem, which is great. Another group, the other half, thought, how do I make this stop annoying me so I can get back to coding? Which means they were willing to contribute more to the ball of mud and keep shipping code on infrastructure they knew didn't work. So the group of us that did want to fix the problem got to work on it, and within 2 weeks, just from these sets of tests, we were able to isolate common sources of instability and finally get in and see, well, let's fix this, let's shore up this, and within 2 weeks we had stable infrastructure, and these tests stopped yelling at us all the time. And that meant when they did make a noise again, something strange had happened. So that's sort of the system test. Now, some people are probably going to say, well, that's what monitoring and alerting is for. And yes, those tools, most companies I've been at have access to all the tools they ever need to do any and all of these things. but a lot of the monitoring and alerting that is set up is mostly geared towards production, which is fine. But in your lower environments, there usually isn't too much of that set up. And most monitoring and alerting is there to tell you when something is broken, which doesn't mean it's operating. It just means it isn't broken. So there's kind of this half step in the middle where you just need to make sure it's okay, not when something drastically bad has happened. So there's a slight nuance to it that sometimes comes up in a lot of companies. The other thing about it is when you have the monitoring and alerting solutions in place, usually there's a bit of conversations that people have to have about, oh, are we going to use it that way? That's not what we should be doing, kind of stuff. But not many people will stop me from writing a bash script that pings things. So shortest path, right? So that's system tests. Really good way to immediately start to stabilize the infrastructure behind a ball of mud, because it is sometimes part of the reason why there's so many problems. And it doesn't take too much effort. You don't have to know a lot about testing frameworks or anything else. Like I said, you can just run a bash script that pings or logs into a machine. Over time, you may want to evolve these to begin to assert different types of operational correctness or correctness itself. So in the beginning, I wouldn't advocate that you go make sure that the schema in a database is correct, or that you're necessarily even running the right versions of code. What I would say is at first, just make sure everything is running and you can talk to each other, then begin to add on these other things. And the reason for this is we want to be careful about how many variables we introduce into this testing effort. A simple test means it can really only fail for one reason. A complicated test might fail for multiple, and in the beginning, we don't really want that sort of extra added debugging effort because of our tests. So kind of, how do I put it? Put that sort of clever version of ourselves behind for a minute as we write just the basic, simplest things. And then once they're passing, we can add another layer of complexity in. So that's system tests. This is the one that you can do in parallel with the next one, which is everyone's favorite, unit tests. I actually wish I didn't have to talk about unit tests. I would love to skip to other types of tests here. But what I have come to realize after about a decade of doing this is when there is a ball of mud, the reality is testing isn't usually a big piece of that ball of mud. And that means that the developers working on a ball of mud typically have let their knowledge and ability of testing atrophy. So there is a lack of skill and practice around testing. So if we were to jump ahead to some of the more different types of tests that might have a bigger bang for the buck in terms of stabilizing a ball of mud, we may actually cause a lot of harm. Because when tests are working well, they eliminate sources of problems for us. They eliminate the variables of what could go wrong. When we have bad tests, they double the amount of things that could go wrong because your tests can be a source of bugs. So we have to develop a certain level of skill and ability with tests before we introduce the likelihood of that kind of a problem. The best way I know to do that is with unit tests. You do still get benefit in terms of the more of these you write, the more you can begin to detangle your code while eliminating small types of bugs in it. But the sort of, is our system correct in a high level, we can't touch that yet with unit tests. So the recommendation is you start with unit tests. And here are my rules for teams to do this. The first one is we add 2 new unit tests for every work item. I mean, work item, it could be a story, it could be a task, it could be a subtask, it could be a whatever. However you kind of chunk your work, add 2 new tests whenever you're done with that chunk of work. You also have to run the tests and they have to pass. Those last 2, I hope more than a few of you are chuckling at that. But again, I have found that a lot of teams may be willing to write the tests, but they want to run them some other time. Maybe they want to run them overnight, or they want to run them at the end of a sprint. The problem is that if we wait to run them, we now can't associate the failure to our change. And we need that level of immediate feedback. The other thing I would say about this is why I'm saying that it has to be that we add 2 tests for every work item. The common thing people are going to want to do instead is say that they want to create an item specifically for testing, or they want to create a sprint for testing, or a whole testing project because we've got to catch up. I'm going to strongly recommend that you resist the temptation to do those things, because when we create a specific item for testing or a sprint or a project, we're fundamentally deciding that testing will end, which is fine if you also stop coding, but that's never the case. So we are immediately sort of saying that because we're going to put a box around our testing efforts, we're also immediately going to say, I finished my tests, I hope they stay around forever and work, which isn't going to be true. You're going to create legacy tests by doing that. So the fundamental shift is testing now has to be incorporated into our development process if we are going to have the benefit of these tests. So have a conversation with your team about this. You don't need everyone to have consensus that, yeah, we're all going to do it. What you do need to have is consent, which is different. That means that there could be a core group of people that are like, yes, we have to do this, and are willing to take on the work. And the rest of the team is okay with you doing that, even if they're not ready to do it yet. So those are the rules. Now, I'm not going to get into how you do unit tests and all that stuff. What I am going to talk about are myths, misconceptions, and common problems that come up. So this is Ruby code. It's from a project on my own computer that I found, so it's nothing fancy. To be honest, it's actually from a technical interview for a company. Don't ask me which one. But this is Ruby. I picked Ruby because A, I had it on my computer, and B, it's pretty easy to read no matter what language is your favorite or what you know. But if you look down on the line with the number 4, that's the test. It's a one-line test. And this is kind of an ideal. We have a class and we want one test. That's it. So we can do this over and over again. This is easy and this is fast. This is where we're trying to get to. So that's cool. Our reality starts to look more like this, though, in a ball of mud. And this still isn't as bad as what most of you have probably seen, but you see that there's this huge big blob of stuff at the top that is me having to set up dependencies and all this other stuff so I could run one little test at the bottom. Now, this is not that bad, but it is the kind of thing we deal with a huge ball of mud. Everything is tangled up and it's a big mess. And this brings me to the first misconception. Unit, when we say unit test, does not mean class and it doesn't mean function. A lot of people get twisted up about this idea that when we're testing or doing a unit test, we have to test a class. And that's not actually what the word unit is about. The word unit is about the smallest grouping of code required for us to test. So when we go to a ball of mud, we are actually, when we have to test, what we are seeing is what is the actual unit as opposed to the unit we wish existed. And this is important because once we recognize that the units are basically the design that was implemented, we can kind of get over that level of conflict in our head that makes us feel like testing is impractical. It's not that testing is impractical, the design of our code is impractical. And testing is what's letting us see that. Now, kind of as a weird quirk about this, when we write a test against our code, we are essentially creating a client for our code. It's an external piece of software that is executing against our own. So when we try to use and consume our own code, we are, in a sense, having to confront its design. So there's a class that should do a job. Great, I want to use it. I didn't, 35 other dependencies I had to use. In other words, our code is not usable by an external client. Now, not all of our code is meant to be, but it does give us a good, quick indication of, did we live up to all this loose coupling and design principles that we talk about? Testing will immediately show us that's the case. But the bottom line with the whole unit conversation is kind of to try to mentally come to terms with unit is whatever that is to write your test. And if it's huge, that's just the unit. If it's really, really small, the unit is really, really small. That's a design choice. So we just have to acknowledge it for what it is and get on with it. This is going to lead me to the next thing, mocking and not mocking. Probably the most controversial thing I'll talk about in this talk. One of the more common approaches when we deal with all those dependencies is to begin to mock them out. Now, mocking is a very specific technique. which is not necessarily the same as stubs and fakes and all that. But there's a really good article by Martin Fowler on his site about the differences between mocking and non-mocking. I personally do not mock, but if you're going to mock, so when we try to write those tests, we are immediately going to get confronted with the pain dealing with all those dependencies. Mocking tools allow us, they're like taking like a pain relief pill. We can deaden the pain of those difficult dependencies by kind of using the tool to carve off the hard parts so we can get to work. But what we didn't necessarily do is fix any of the design problems that caused the pain in the first place. And that's fine. Mocking, if testing is a skill, mocking is a specialized skill. Nothing to be afraid of, but there are risks. First, by only accepting the pain pill version of relief, we don't actually develop our ability to redesign the code so it's easier and more loosely coupled. Next, in a ball of mud scenario, because there is so much mocking to do, you can very, very easily wind up in the position that you are testing mocks instead of testing your code. And I would say this has happened repeatedly in my career where the team goes full in on testing and they start mocking everything so they can get to testing. And then sure enough, all the tests are passing and the application won't even start. You can very quickly wind up with a complete shadow implementation when you mock that can backfire. And it's usually really hard to know if that's happening until it becomes completely obvious and then it's all that way. So if you're going to mock, be extremely careful with it. If you're going to try to not mock, someone is going to say, what about databases and networks and expensive things? And I'm going to say, don't mock them. So expensive tests in terms of how hard they are to write and external dependencies do not have to be mocked. They can be isolated through design. So a common problem in a lot of these balls of mud is that even though we think we'll have a layer of things that will talk to databases and talk to APIs, but that's actually many things do that. What we don't ever actually get to is where we've isolated out the idea of an external API into a single representation. Once we have a single representation, that test there is the only one that touches the API. Everything else, we can put an equivalent in, an in-memory version, a cache version, a whatever, and by contract, it's the same. So I've isolated the expensive tests by design. That's where we want to get to. I personally like the awkwardness and the pain of everything because it forces me to solve the problem because I'll go crazy if I don't. But that's just me. So that's mocking and not mocking. You do not have to mock to solve this problem. And if you do want to mock, take a lot of time to develop the skill and be very careful that you don't wind up in the shadow implementation world. I now want to talk about your old tests. There's probably a few lingering. They probably haven't passed in recent memory. Turn them off or delete them. Now, some of you are going to be like, oh, we can't ever do that. But if these tests aren't valuable to you and we don't care about the results, they're not useful to you. Before you turn them off, delete them though, I would go ahead and make a note of what they were attempting to test so that you can make sure that you can cover it in time. But the reason why it's not worth necessarily trying to clean those tests up is we don't know really the time at which those tests were ever relevant to know what has changed between now and then to fix it. In other words, those tests were a snapshot of reality some time ago, and we'd have to understand that world plus everything that's changed to make those tests valid again. So it's usually not worth that much effort. You can probably write another test that asserts the same thing with what you currently know. So I would say get rid of them. One of the last things I want to talk about is test independence. Now, most people I've met think test independence means that their code has to be tested independently of everything else. That's not what it's about. It's saying that your tests have to run independently of one another. Or to put it another way, you should be able to run any one of your tests in any order and have consistent results. Many code bases do not meet this criteria, and a ball of mud most assuredly won't. This is really important. When I mentioned before that you can wind up doubling the amount of debugging and stuff you have to do with bad tests, test independence is why this is such a problem. This is the cause most of the time. So if you imagine you had 500 unit tests that run, Now, if you have them, if they're truly independent, they're going to run consistently, and there's not going to be an issue. Now, if you have a dependency issue, and let's say the 200th test fails, all 199 before that could have put your system in the condition to cause that test to fail. That's the problem of test dependencies. So not only do you have to worry about your change, now you have to worry about all the tests that ran ahead of it as a cause of a problem. That's a nightmarish world to live in. I was working on for a company, and they had this exact issue. They had been running full steam ahead at the more complex types of tests, which just adds a lot of extra variables. But they immediately had introduced a test dependency without realizing it. That meant the tests never really passed, which meant they always failed, which meant we were shipping to production regularly without having any idea if anything worked. That was the case for about a year and a half while I was there. Eventually, I was able to track down the source of dependencies, which was one line of code in the entire test suite that was basically creating a bad state. Sometimes I fixed the bug and all the tests now were able to pass consistently, and now we had confidence. But it took a year and a half of that. In other words, this is a super expensive problem to have in your tests. So how do we deal with test independence? Here are 2 rules to help you out. The first one, every test runner supports an execution in a random order, flag or something else. Most unit testing frameworks do it by default, but if you're going to get into other types of testing and other types of frameworks, you may need to look this up. By running them in a random order, you are basically going to allow test dependency issues to become very, very clear because a test will fail. What you won't know is if it was a dependency issue or a bug. So the way we kind of narrow that down is by running them multiple times. Now, I'm not saying you want to run them multiple times forever, but for the first few months while you're getting the hang of all this, just set your tests to run 2 to 3 times consecutively. No changes in between, just run them back to back. The reason for this is when you have them random and something fails, and you run them again and it fails in a different way, congratulations, you have a dependency issue. If you run them back to back and it fails the same way, you have a bug. So these rules will basically kind of force you to learn how to deal with test independence a little bit better. Now, I mean, I can tell you the short answer is most everyone knows the value of a setup method in your unit tests, put the system into the state you want. What you'll find consistently missing is a teardown. Or they try to put the teardown into the setup, but people get overly clever and try to optimize those things way too early, and it leaves a dependency issue. So these rules will help reinforce how you learn to do your setup and teardowns. Okay, so behind the scenes, we're talking about these really hard first unit tests to write, and they may take days to write, which is why only writing 2 in the beginning will feel like a lot, and over time 2 will feel like too little. So add more if you want. But they'll be really, really hard, and the tests will be really, really slow because there's all these dependencies. Even if you mock them, there's going to be stuff that's just woven into all these tests. For example, in a Java or Spring Boot application, your tests are going to instantiate Spring Boot. The entire framework is going to launch. There's going to be all these expensive components to your tests that, honestly, we may not need them, but they're there in the beginning. So there's going to be a lot of temptation to speed up our test suite because we have to run them and keep them passing. So, of course, someone's going to look up how to parallelize or use threads to run them. I'm going to say all that's fine, but your best way to optimize your tests is paying attention to those design problems, not necessarily the parallelization options that are available in your tests. See if you can look at how your code has been coupled. Begin to separate the coupling from databases and networks and frameworks, especially really big ones. The more you can isolate your code and loosely couple it to things, the faster these tests are going to get. Then you're going to have more certainty about what the results mean. It's really not fun to write a test that you think is simple, but actually because of the framework that has been deeply coupled in, there's a configuration option, and now you have to look that up because all you wanted to do was add 2 numbers, but you forgot to configure your framework correctly. That's not fun. So that's my sort of bottom line here, and those are the 2 techniques that you start at the same time. You start the system test to make sure you have stable infrastructure, and then you begin to do these unit tests for a couple of months. Now, while they won't remove all the bugs in your system, what they will begin to very, very quickly do is once you have passing tests, you can begin to clean things up. And you know you're going to be safe because the test can keep passing. So you can begin to attack some of the ball of mud design problems through these unit tests. If you wanted to do something more complicated like a strangler pattern, well, how do you know you strangled the right thing? The tests are there to protect you. So you're still going to be able to get traction on redesigning and refactoring while having a set of tests that are running in a stable way. What will be missing is a comprehensive way to know that your ball of mud is operating correctly. So where I would probably want to go next, this is 3, so we've done 2, I'm going to 3. Where we probably want to go next are smoke tests. So smoke tests, in the way I like to do them anyway, is identifying the 5 to 10 critical use cases of the application and writing a set of tests that confirm those use cases work on a fully running application. So all the infrastructure is there, it's all running, and you run through these tests, and they're pretty quick. They'll tell you whether or not those use cases are working or not. If they fail, you've got a big problem, you've got a massive issue, so you got to deal with it. So they can give you that quick win. Now, the reason why I don't recommend that you start here is because these are running against everything. We have to think about what an error means. So when a test like this fails, the things that could be wrong are the code, the state, the database, the network, the infrastructure, and on and on and on. In other words, everything that exists in our ball of mud is suspect to that one test failure. That is a really hard thing to live with and debug. So by stabilizing infrastructure, we've eliminated certain categories of problems there, right? We know the servers are running, we know that stuff's basically there. By having unit tests, we have now begun to eliminate code changes as a problem, which the more this grows, the more we're eliminating sources of issues. So when these tests begin to fail, these smoke tests, we can begin to say, okay, it's state, it's data, it's a misconfiguration. That gets much easier to begin to trace out. So in other words, a way to think of this is every time we add new types of tests, we're trying to remove a set of variables that could be at play for why things go wrong. And in a ball of mud, it's all one big mess. So as we begin to add these types of tests, we can begin to systemically remove variability in it. And the smoke test coming after the couple of months of these unit tests means we have the competency to deal with test independency. We know how to write a test. We know how to see the design issues behind the test. We're ready to deal with the failures of them. And we've kind of dealt with some of the, okay, how would I go about debugging this issue now? So we're prepared to take on this next level of testing. And from here, you can grow into wherever you think the problems are for your big ball of mud issue. It could be you need to go make some checks about the database. It could be anything else. It just depends on where the problem areas are as to where you go to test. The foundation and practice that you've developed so far is what's going to get you there. So those are kind of my two ways to start. It's not a comprehensive, this is everything you have to do. It's just the 2 ways to begin. I've been able to do this with a number of clients and a number of companies. And the results, even though it sounds like a slow process, it comes out pretty quick once you get enough people on board with this and get moving with it, because they have more confidence in how to approach the problem. I guess where I want to close with this is, I kind of hit on it before, but balls of mud are written by smart people who are well-intentioned and thoughtful, which is probably every one of us. And so we have to be careful thinking that we can well-intentioned and thoughtful our way through making a ball of mud. We have to do something that is fundamentally different, unintuitive, or even feels like it's wrong to have a chance at getting past this. And I have found that testing is one of those things that hits that mark most of the time, with the extra benefit of it will point out the design problems because it makes testing hard when it's poorly designed. So you have a feedback mechanism in place to alter how we see the design. So instead of talking about single responsibility or dry, our tests are going to begin to tell us how well we did with that, because it will make our testing easier if we can live up to that principle. It'll also give us thoughts as to when that just can't be true. And again, the unit's going to be a little bit bigger. Okay, that's intentional. So the bottom line, I guess I want to summarize this with, is you don't have to suffer a ball of mud forever. You can make progress. It will take time. But one of the fundamental steps a lot of teams that I work with have to go through is kind of coming to terms that the things they've done in the past are what created the ball of mud. So if they want a different future, they have to fundamentally do something that is radically different. And testing is a good way to get started. So that's kind of my talk there. Here's my introduction now at the end. This is my picture you'll find of me pretty much everywhere. That is a squid that I'm eating, not a piece of pizza. So I work as a consultant building really high-performing teams that take on impossible challenges. And then by night, I coach developers to make sure they get the career they want and the lifestyle they want. You can go to my website and read articles about it. That little sleep bio link kind of has my social media and all that stuff. I'd love to get to know any of you on LinkedIn or have you join my newsletter. But yeah, that's me. And I'd love to hear whatever questions or thoughts that you have. Thanks.
Great, Ryan. First of all, thank you very much. I was waiting until you put your headphones back on so you can actually hear me. It was a great talk. I learned actually a lot of new things. So thank you very much for that. And of course, we do have some questions for you as well. And with we, I mean our participants.
Great.
The first one, and let's just say it's a tough one. How do you implement any form of testing in a project overloaded with singletons? Can dependency injection be implemented iteratively? And let's just say another participant already answered that question with, that's tough. I mean, he did answer in more detail, but of course we want to hear your take on that as well. So
singletons are brutal because of their inability to control life cycle. Depending on what tools, so depending on what you've done or where you are, like if you're in Java, you can use power mock and then start mocking out the static sides of things. If you use Spring, it's all a singleton and you want to isolate from your framework because that's what you do. If you've created your own singleton, you got kind of two ways to do it. First, you can fake it by creating a public constructor and treating it not like a singleton. That's not really a great way to do it because it's not real. The other way that I kind of deal with it is just accept it as that's the unit. It is a black box at this point. Where you may want to go past that is instead of treating it like a singleton with state, you want to convert all of it to be more of a static thing or a builder pattern kind of a thing. So it's less about a single object that exists and each method can create its own singleton for a second, do its job and kill itself. So you can reuse scope to control its own singleton. Different ways to go about it, but no, that is a hard problem. That's why singletons are typically like a shame on us. It creates some weird design problems for us, and it's a tough one. I don't have a smooth way of getting through it. It's contextual. Yeah.
Another question from one of our participants is about your opinion on snapshot testing.
I don't have a lot of experience with snapshot testing, so I couldn't really say. If it is what I think it is, give it a shot, right? Like, even though I'm advocating for these two particular types of tests, I'm doing them because of their low level of variability in a system. So when something goes wrong, you don't have to think about everything is at stake. Everything could have been broken. And I think a lot of teams benefit from that baby step type approach for a little bit till they have confidence to take on like everything is at stake now. So if you want to try it, but you have to be willing to acknowledge if something goes wrong, what could be the source? And it will probably be everything, which is not fun to debug.
Yeah, definitely. And I think we have time for one final question. In your opinion, what's the best way to write parameterized tests?
So if we mean parameterized tests as in like there's an external source of parameters we're going to inject into our tests?
I hope so. I mean, the person who wrote this question is free to add more detail to it. But let's just go that route, I would say.
So in the world of unit testing, I would not necessarily do that. And the reason comes back to when a test fails, I want to know exactly why it failed for one reason. I don't want it to be in the middle of a set of iterations. So like kind of there are these guidelines for a lot of unit tests, like you don't typically want to have iterations, you only want to have one assertion. Now, these are guidelines, not rules. Parameterized tests are kind of an optimization strategy, so we don't write a bunch of tests that are similar. But I think once we get to a good state with unit tests, it's actually really low effort to add another test that is topically similar but is asserting a different level of input. That is, again, like there's a thing called zombies for testing where you go 0, 1, many, between, something, something, something. I don't remember. Each of those would be its own test instead of parameterizing it with each of the inputs to do that. And the nice thing is when those explicit tests fail, you know exactly what happened. Instead of when the test fails, you have to go say, okay, this test was trying to figure out these things at this iteration. Now I want to breakpoint it and debug it. We want to eliminate the amount of investigation we do when a test fails. So I typically won't parameterize in a unit test, and I still.
So you want to be as specific as possible whenever you do testing.
Mm-hmm. Well, and if you think about it like this, like some people call it like degenerate tests, but there are a set of tests we would typically do where you would say like, all right, I'm going to assert this happens when I put a null through, or this or that or whatever. These tests are just meant to be guardrail tests, so you might break a guideline and put all of them in one test. But you know when the degenerate test fails, some ridiculous thing has happened. That's not so bad as a counterpoint to what I just said. But if it's a real test, one thing is supposed to go wrong. So you know from the error message in the console exactly what has happened. You do not want to go back in and start looking.
What is the craziest thing that you have ever seen go wrong?
Craziest thing I've seen go wrong. Trying to think of a good example. I mean, I can tell you so maybe not the exact answer we're looking for, but one of the first times I was really, really getting into a ball of mud, they had the equivalent of a God class. So it was 3,500 lines that basically indicated how everything worked. And it had, you know, the if logging debug is enabled, business logic kind of problems. So for me to test it, I actually had to reconfigure the logging framework to get access to a set of business logic that was contained in an if clause for logging. And that code base was full of little gems like that, or manipulating an input parameter because they thought they were doing C++, but they weren't. So that was a fun one. The case where it was a one-line change to fix the tests, that was quite literally, I think it was a one-character change where they were, instead of mutating a thing, they were creating a new one. And so I had to make it so it mutated instead of created a new one because we needed to keep the state. So I don't know. I don't know if there's like a crazy one, but it's always surprising. I don't know. It's always surprising to see what you unearth.
It's always fun, right?
Yeah. I hated this kind of stuff most of my career. And then I wound up kind of developing a deep fascination for like, can I even deal with this? Can I make headway? What am I going to learn by doing it? And I wound up really liking big, nasty code bases a lot more than Greenfield. Because Greenfield, I don't know.
We can see this in the way you talk. I've actually never seen somebody talk as passionately about testing as you do. So thank you very much for joining our Congress. Unfortunately, our time is up. To our participants, if you're interested in hearing more stories from Ryan, or if you want to connect with him, as he said, check out his website, follow his socials, or connect with him here in the Swap Card app. Ryan, thank you very much for joining us. I hope you had a great time. I hope you join us for the rest of the Congress as well, if there are some other sessions that are interest of you. And with that, I want to close this session and also this part of the day. So whoever goes to watch football now, do that and enjoy that. Germany is playing against England. This will be a great one, I hope and I think. And we see each other tomorrow at 9 a.m. for the first sessions. I wish you had a great day. I wish you a great evening. Once again, Ryan, thank you very much. Have a good evening.
Yep. Bye, everyone.
Or morning, wherever you are.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.